Bonjour, good morning. It is Monday the 17th of August 2020. It's not that great a date really, is it? Right, basically, because of the old bullshit virus, I've had to rejig my diary slightly to my advantage. So, I am down at this old French bungalow, because it's not really a house, let's be honest, but I will keep calling it a house. So basically, I've got 4 days this week and 4 days next week. I'm also going to be going to go up to John and Coco's for a couple of days on both weeks just to keep the pennies coming in. So it's going to work out really well. A little bit of a different video today. What I thought I would do is do a DIY how to put up a metal partition wall and plasterboard it. How-to videos are really handy. One of my most watched videos on my other channels had over 300,000 views. So it's obviously something people enjoy learning about. So I thought, well, I know a lot of you guys who watch like to try and do it yourself. Obviously, I get a lot of you personal messaging me and chatting and stuff, and I know you are keen to learn. So yeah, let's show you how us so-called professionals do it. Okay, first things first. Basically, you want to sweep your floor clear, so there's no debris on the floor. And also, I can't stress this enough. Whenever you're drilling into walls or floors, you really need to know what's going on. So what is underneath this floor, what is in this wall. Now on older builds it can be a lot more tricky, especially in France, because they seem to not care. They don't tend to work to spec a lot of the time, so you can basically find anything. So really you want stud detectors, metal and water detectors to see what you're going through, or just think about it logically. If you're near a toilet, basically you should know there's pipes running here, there and everywhere. As we well know, this has got underfloor heating. We've got a 50mm screed, so really we don't want to be drilling down no more than 30-40mm max at the most. Also, because you know it was me that set it out, I know where I put the pipes, and there are no pipes here. But even so, I will err on the side of caution and be very careful with my drilling. Because let's be honest, if you hit a water pipe, or even worse, an electrical pipe, it can be dangerous or just costly to get repaired. So yeah, just be aware of that. So yes, a quick sweep of the floor. Voila! Right, for setting out, obviously setting out's down to the individual. You know, back home when we used to do it, obviously we worked to plans. You'd get all your measurements, you'd have a wall that you'd be working off of, you'd just stick off of that wall. And off you go, making sure everything's parallel and square. So in this particular example, for the wall that I'm building, we're going to be coming parallel off of that back wall, because obviously you want the room to be parallel. So I will measure from there to here, do a pencil line. I will do the same this end, and then we've got a choice. Like obviously I'm a professional apparently, as I keep saying, so I've got a laser. If you haven't got a laser, you can use a string line. If you haven't got a string line, you can use a straight edge, a straight bit of wood, a straight bit of metal. You can even use a bit of string with no chalk on it, stretch that out and then gently pencil line along it. It's DIY, you've got to make it up if you haven't got the tools. So I'm going to use my laser because I can, but if you can't, there are the options. Right, I'll just get this out. Okay, so I've measured from there to there, from there to there. It is 434 centimetres, so we did a pencil line there, and then also we did a little X marks a spot so we know the metal's on that side of the line. So then that way, when we put the metal along like that, we're not either side of the line, which will make it wrong. So just be aware of that. Also, we've got a door opening going in, so that's that pencil line there, and the width for the other side is there. So we will now put the track down and fix it. Okay, so normally if you're a professional, when you're putting your bottom track down, it's got multiple names: sole track, bottom track, sole plate. I just call it bottom track, top track. Sometimes I call it other names, just depends on the day and the mood really, but bottom track. Basically what you would do is you would put it in position, get it on where your line should be, and then you'd have what's called a spit gun. It literally just fires basically nails via a little charge straight into your concrete. If you're going into concrete, obviously if it's wood, you would use wood screws, but you would just literally go bang, 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 600 centres. I don't have one of those guns. I don't do it often enough to really warrant it because they're quite expensive, and as we're doing a DIY video, you're sure as hell not going to have a £600 gun either. So the easy way to do it is you get your bottom track, you flip it over, purely for convenience, so you know you're getting your holes in the right place, 600 centres. You know, that's quite a common spec for drilling and fixing things. So basically, every 600 we will put a hole. So it's as simple as getting your metal drill bit and drilling. So I'm not damaging my nice new floor. I've actually got another big track underneath, so I'm drilling into that rather than into the floor and leaving marks. You can then put it in position where it needs to be. And then, same again, if you're DIY, you should, you know, if you're going to need a drill, hammer drill. You should have hammer action on it, so select hammer action, put your drill bit in, your masonry drill bit, and then just drill in. Now obviously, like I said, I'm working with a 50mm screed. I only want to go in about 30-40mm, so that's what I'll be doing. You get so many different types of drills these days. Like I've got a battery operated SDS drill. This is my favourite weapon to use, obviously because it's portable, it's easy. There's my depth set there. But also, new tool Monday, I've just picked up a new Bosch SDS drill because my Makita one's just given up the ghost on the hammer action for chiseling. So I've got this, so I'm just using it purely because it's brand new and I want to use it. But normally I would be using this bad boy. But like I said, any of these drills will do as long as it's got a hammer action on. And like I said, select your depth, because the last thing you want to do is drill through to the wrong depth. One thing I'd also say, when you're drilling your metal, make sure you hold it in place because it has got a habit of slipping around and moving. Okay, once you've done your drill holes, you've got a choice of fixings. Now, ideally, metal hammer fixings, they're the best really. No nonsense, strong, tough, reliable, because once you've drilled it, you would have kept that in situ there and you would have just got your hammer fixing, boom, bang, done. I haven't got none, and they're expensive over here, and I've got loads of raw plugs and loads of screws, so why would I go and spend money on something when it's a waste? And it's DIY, do it yourself, so you know you are going to use what you've got around. So the thing to do is brush it out the way. Go get your raw plugs. I ain't got time to do fixings, everyone knows how to do that. Push your raw plug in, put your screw in, that will be your bottom track fixed down. Okay, so I've just got my raw plugs in. I've just got some decent quality little screws. They don't have to be massive or long, as long as they're decent. Right, always check your work just in case something moves before you move on. So just by putting that on there like that, I know it's not moved, everything's good, happy days. Right, the next thing to do is transfer this up to the top plate. Now I'm going to show you how to do that. Okay, I've just set everything ready up. So basically you want to measure from that wall to that wall, because that's the wall we're building between. But on this side, just particularly on this side, you need to allow enough of a gap for the plasterboard to slide down so you can tie the wall in. So what I mean by that is, see this gap here, plasterboard will run through there. You put what's called a locking stud there, so when that wall goes there and that wall goes there, you screw them together, clamps it all together, and then that makes it all structurally nice and strong. So basically that gap there will be emulated up there. Now, as you can see, I've got my adjustable prop, or dead man, as we like to call it in the UK. So that's been put in place just to take the end of it to make life easier. You can make them up yourself with some 2B1, just a couple of bits of length of batten with a little T-piece. So that's that. And then because this wall was already here, I've already put that stud work, bit of stud, in place perfectly plumb, which means I can put the top track straight on top, put it on top of the prop up there, then all I've got to do is just do the transfer from top to bottom to put it in the right place. And I'm going to show you how to do that now, a DIY style, without a laser. Okay, so I've just cut a stud for that side, ready to transfer the bottom track measurement up to the top track, so I'll just explain as I'm doing it. So we can rest that on that stud because we've already got it there. Right, so we can prop it like that, get it all in place, then off with the stud in. And then it is as simple as, now that the stud's in that bottom track, you just get your level, put it on the stud, and then just adjust it until it reads plumb. Just remember the track pushed that way so you retain that gap up there, which it is, and then just put a fixing in. So this is a plasterboarded ceiling onto the metal ferrule, the metal rail system, so we just want some plasterboard screws just to screw it into place. I can see where my fixings are because we've still got the screws in place, so that's easy enough. And that's it, done. It's simple as that. Now obviously if we were doing this freestanding without that wall there, it would literally be the same both sides. It's just a little bit more fiddlier because obviously you've got to hold the stud whilst it's wobbling around. I would just get someone to help, or just bear with it, or just get a couple of props. Just pinch it so there's just a little bit of movement, so it's just holding it, and then that way you can just slightly adjust it. But it's a fairly simple process. So now what I'll do is I'll put the fixings in every 600 centres, and then we will infill and actually make up the metal stud wall. Okay, to make good use of your materials, depending on which way round you're going to start the wall. So if you're going to plasterboard that wall first, you've got to allow for that bit of plasterboard, so adjust the tape accordingly. But personally, because of the thickness of this metal stud, we're going to board this first, which means we've got plenty of meat to screw to, and then we can screw on there where we've got plenty of fixing. So I'm going to mark out 600 centres. On just normal partition walls like bedrooms and stuff, it's 600 centres. Bathrooms and kitchens, you do 400 centres. That's because they tend to carry more weight, i.e. they have tiles, wall units and all that on it. Now, I work to the British Gypsum White Book specifications. You can download it quite easily. It's basically the Bible for the dry lining industry. You can just put one metal stud in. When you board it, you put a full sheet this side and then you stagger the other side. That stops the wall flexing. By that we mean a 1.2 metre board this side, then on the other side you put 600 and then another 4 board on the other side, and then basically have that effect rather than that effect. Because the metalwork is really cheap over here and it just makes the wall that bit stronger, I will be doubling up the studs. You don't need to, but for the sake of literally €2 a stud, It just gives that ball that little bit more rigidity. They're crap, in my opinion, they're crap anyway, but you know, they're straight, don't have to worry about termites, they're easy to work with, they're quick. Personally, if I was in the UK, I'd be using decent CLS wood because it's just a better material to work with, stronger, more workable in my opinion. Yes, it's not as quick, yes, it's more expensive, but I think you get a better job from it at the end of the day. But this is what we're working with, so this is what we use. Right, I've got my markings, now we'll cut the studs and put them in between. Okay, so the studs are going to be getting cut at 2965. So we hook it onto the end of the stud, we find 2965. Metal cupping snips. If you can't afford them, you need to reevaluate your life. If not, you could use a hacksaw. I wouldn't recommend it, or a grinder. But you literally just where you've marked it, snip the top section of it, so hold it like that, snip that top one, snip the bottom one, and then put the snips on the end, bend it down like that, and then just cut off the bit at the end. We're working on a huge project. We basically have a metal chop blade, just a huge saw, and we'd have packs of these in place. We do the one measurement and then we cut 10 at a time. But obviously we're not on a massive site and I don't have a massive metal cutting chop saw. So we're using snips. Right, that's that cut to height. We're now put that into place. Okay, I've just cut all the metal stud to height. What I'm going to do is I'm just going to do a quick dummy run to show you how we would set up the wall normally without doubling up the studs. There's a doorway here. At this current moment in time, I don't know what the door opening sizes are because I haven't bought the doors. I'm making this house disabled friendly. My eldest brother's in a wheelchair, so I'm aware of people's disabilities and the need to be able to make their life easier. So that's why all the corridors were nearly 1 metre wide. The doors will be the 900 doors as wide as I can get them. So basically, with metal stud partitioning, when you're building the frames up, you would normally put wooden battens slid inside of there. So then that way, when you screw your door liner to it, you've got a decent fixing rather than this metal which doesn't bite that great. I currently don't have any battens, so I'm just going to fit this in situ temporarily. But yeah, there would normally be wood in there. So as you can see, we're putting the metal in, we put it in sideways, put it in position so it's near vertical, and then a quick turn, and that pops it in place. So that is basically our door opening, which is obviously going to be a lot wider than that, but I'm just showing you temporarily. And then obviously I've put them on the marks that I've done on the floor, and then it'd be a case of just plumbing it up. Okay, I always like to fit my metal together with the 13mm wafer-headed screws, which are these bad boys here. You can obviously use a crimping tool. I'm personally just not a fan. The main reason for that is just when I used to work commercially, a lot of the times the boys would crimp stuff in place, but just because of the nature of some of the projects, for example, plasterboard is 1.2 meters wide, but it's a manufactured process, so there are tolerances, so it can actually vary by quite a few mils. So this is so precise. If the boys set it out over a long run and crimp it all, after maybe 2 boards, because of those, couple of mil, it starts to run out, and then when you've got to pop the bloody crimp out, you've then got to get a pair of pliers, crimp it all back in place, and it just makes it hard. Whereas if they're screwed, it's just a case of undoing a screw, sliding it along and screwing it back in. I just think it's easier, and I just think it's a better application personally. It all comes down to personal preference. With the position of the stud as well, you want it so the open section is facing that way, so when you board, it doesn't twist. Because if you have it the other way around, when you're trying to screw, that will just keep poking in and it ends up like slightly twisting it. So when your boards are butted up together, they can just be you know, not quite flat. Doesn't really matter, no, the taper or the plaster, it would get hidden, but it's just, that's the way you're supposed to do it. Right, so how that's set is how you would do your wall, and then you would just put some wafer screws either side, if you can get to both sides, and then happy days. But like I said, what I'm going to do now is double it all up just to make it better. Okay. Now, obviously if you're a regular watcher, I discussed this the other day, but keep all your stud work all the same way round, so your service holes will all line up. If you keep flipping your studs around, these won't line up. Then if you're having to run any cables through, it just makes life extremely difficult, as in you won't be able to do it. Right, so basically that is that all done. There will be a head detail for the door, which means whatever the door height is, we would put a bit of metal across. But like I said, we don't have the sizes yet, so that will have to wait. But that's very easy to do. You literally just put a bit of metal across. So if you can't work that one out, there's no hope for you. Right, basically now that's all set out, I can put up some plasterboard. So I'm just going to get that all screwed together, which I showed you where we get the wafer screws. We just clamp it together like this, making sure that's nicely lined up, and we just put one screw down the bottom, one screw near the top, and one in the middle. That just holds that all nice together. I'll plumb it up, and then we're ready to go for the plasterboard. Okay, this is all screwed up now, nice and solid. Right, because we're working at quite a big height, it's nearly 3 meters, tape measures, like I have a selection of tape measures 3, 5 and 8. Now using a 3 meter on this, obviously you'd be at the end of its tether, so worthless. 5 meter would be pretty handy, you know, not too bad, but for the bigger stuff, get a decent tape. It just makes life a lot easier for working with. Now, a lot of people are really cock-handed when it comes to using tape measures over long distances and that. It literally all comes down to technique. So I'm going to show you how I do it and how a lot of us professionals do it on site, because everything I've learned was from the old boys who learned, you know, from back in the day. So it's like, you know, passed on. So literally offer it up so you're up onto the ceiling. Just run it down a little bit so you're there. Pinching it in place, so if that happens, it doesn't matter. And then you just stretch your arm out, use your knee, again, and then you're where you need to be. So we can look down, it's exactly 297 centimetres. You can allow a few mil off the bottom to make life easy, up to 10 mil really, it's entirely up to you. I know this ceiling's nice and flat, and I know the floor's nice and flat, so I know I can cut it quite close, so I'm just going to allow 5 mil. So 2965. So I'm going to now take you over and show you how to cut plasterboard. 2965. Because you should always measure twice, cut once. Or if you're a dyslexic nightmare like me, cut it several times and still get it wrong, because you ain't got a clue what numbers mean. Okay, so 2695 is the measurement I want. Same again, these are 3 meter long boards, so either a 5 or 8 meter tape is ideal. I'm going to be using my 5 meter. Now, if it was me just doing it without thinking, you know what I was saying about being dyslexic? Now, because I know it's 3 meter high, 2695 is too short. It was 2995. 2965. Every day's a struggle. Right, 2965. I'll switch the numbers around. Right, where were we? Why would you watch a video where a man doesn't even understand numbers? Right, 2965, not 2695. So, an easy way for the amateurs. I think we're a bit too low. High level production going on here, guys, as always. Anyway, yes, 2995. I'm literally just going to start again. Cut. 2965 is the measurement to get the plasterboard cut to the correct height for that room over there. Right. So, if it was DIY, do it yourself, because you're going to be rubbish at it, you're going to mark the top 2965, and then you're going to measure along the bottom 2965, and then you get your nice straight edge. Any type of utility knife, I use a Stanley knife, this particular one, an Irwin one, because it's the mutts and nuts, but most of them work, the retractable ones, anything. And you can literally just line it up like that, and cut it down, which we call scoring, and then you snap the back, cut up the other side, and that's it, cut. But I want to show off and show you the way I do it professionally and how all of us professionals do it. So, I'm going to pencil it in. Now this is where the 3 metre tape measure comes into play. Now, I've done this literally tens of thousands of times. So, you get your knife like that. You hook your 3 metre tape, because it's got a littler end so it's more workable, over like that, and you pinch the two together, like this, so it's just pinched together. And then, starting at the top, you want to dig it in on the line. So, dig it in like that, you pinch the same on the other side, like that, and then you just run it down, keeping them both parallel. So we just go down, down, and that is how you cut the board, nice, quick and easy, and it's really accurate to within the middle too. And then you literally pull it out a little bit, you snap it like this, so you literally just snap it round on itself. Now you can cut it up that way, but what happens is the paper tears on the other side, it just looks unsightly, so I always prefer to reach around and cut it. So you get a nice clean score line. Right, that's how you cut a bit of plasterboard to height. Nice and easy. Right, let's go get this in position. Right, these 3 metre boards aren't exactly easy to manoeuvre, so before I went off to get it, I opened up that frame because I knew I could. I made sure there was a clear path and I made sure everything was out of my way, apart from the foot lifter, which is always in the way because it needs to be somewhere handy. What's the foot lifter, I hear you say? Okay, now we need to butt it up to the ceiling and against the wall. This is a foot lifter. They're about £10 from Home Depot, or Screwfix because I'm English. You can make them just literally a little bit of wood with a little bit of metal just to give that rocking motion. They're also called door lifters. Really handy for obviously lifting doors into position. Most modern day plasterboard has little markings for the 600 centres, and over in France, which I really like, they also do the 400 centres as well, which is really convenient. So it's literally just a case of lifting it into place. So it's up against the wall, just tipping it slightly to one side so you can get your foot lifter under, and then slamming it against the wall so you know it's flat, and then just lifting it into position. Now this is where metal studs crap because it flexes. Now on that side we know it's in a good position because it's hard up against that wooden wall. This side tends to be a little bit more difficult because it flexes. Like that. If you've got someone to hand, get them to hold the other side. Like literally, they can just stand there like this and just hold it. It just stops that flex, which then makes the screw go off at a stupid angle. Right. That's basically now what we call pinned, so you just pin it in position. We do that a lot because sometimes you just need to get it up so you can do other measurements. Now on walls, the latest spec is 300 centres. So by 300 centres, we mean every 30 centimetres or 300 millimetres, we will be putting a screw. Now they've sprayed these markings every 600. So basically you put a screw there and a screw there, one in the middle, voila! They've basically taken the hard work away from having to roughly guide it into place. Right, I brought a fancy gun to show you. Now this is my collated screw gun. There are many like it, but this one is mine. So what you do is you get your strip of screws, you put it into your gun, and then basically it's like a machine gun for screws. You would then go up to the wall, starting at the bottom, and you'd screw it up uber fast, and you'd have that done in next to no time. Now the problem I've got, apart from the fact it was made when the dinosaurs were still around, for some reason it stopped working when I brought it over. I actually have two of these, and both of them just decided they don't want to work no more, even though the batteries are all perfectly fine. So it's a bit annoying that I've got two of these really good guns, but they don't work. I do need to invest in a brand new one. Hilti do an amazing one. I did used to have a much more modern one, but I sold it because I wasn't doing this as often as I was at the time. So yeah, this is what the professionals use, a collated screw gun. Not this ancient though, but that just goes to show how long I've been doing it for. Dewalt, Makita, Hilti also do what is called a drywall gun. It's basically a high spinning gun with a special end on it which sets the screw to the right depth. This is adjustable, so basically the screw wants to go in so it doesn't break the paper, it just goes in so it's flush like that. So when you tape and joint it, you just go over it and it covers the screw head. Always make sure you use your right screw. This is a coarse thread wood screw, plasterboard screw. This is a fine thread metal screw. So for metal applications, you want 25mm fine thread screws. For wood, 38mm coarse thread. Does it matter? Not really, but you know, right tools for the job, right fixings for the job. You can use any other type of screw gun, so you can use one of these. You can just use a bog standard cordless. It's a PH2. It's always PH2 with drywall screws. So you can use one of them, just a normal drill, or you can even use an impact. Impacts are quite good, obviously, because it's got that clutch setting on it. It just sets them a lot easier. So because obviously you've got more control. So I will show you now. Okay, so I've got my impact PH2 starting at the bottom because then there's less chance of it flexing. And you can just set it because it's really got a good trigger control on it. So that works really, really well. Then you've got just your normal basic cordless drill. So same again. That works just as well. Now the advantage of the drywall gun is because it's got this fancy stopper on it, you haven't got to think, you can just screw. And it just goes straight in like that. No messing around, it's just a really quick process. So if you can afford it, get one. If not, you can use all these. Right, let's get that screwed up. Right, so that's that done. Working at height, anything over 2.4, 2.5 is considered working at height. Obviously, if you need scaffolding, you can't reach, you need extra hop-ups, you normally charge more money as well because it is a pain. It really slows progress down. But tall ceilings do look quite nice, so we're going to have to put up with it. This corner here is actually a cupboard. So basically what I'm going to do is just mark out where the cupboard goes to, and then we've got to work out the centre point of the room, and then we're going to be putting a socket either side of the headboard of the bed. So that would be a good opportunity to show you how to cut out sockets, which is the equivalent of cutting out pipework and anything else. Because obviously if you're going to be installing plasterboard, which is the reason why you're watching this video, you're going to want to know how to cut it out, mark out and cut out. So we'll do that now. Okay, because we've got plasterboard mounted electrical sockets, basically I needed to cut this hole out of the OSB so it can sit in and screw to the back of the plasterboard, so I've done that slightly oversized. Now to cut the actual socket out is as easy as measuring right to left to where the size is. So for example, we're here, so that's 1110. And we just transfer it across like this. I'll just move the board across so it's closer. So that's the first line, and then we just pencil it in like this. And then we measure from the bottom up to see where that is. So it's there and there. To make life easy, you can go that and that. Because you just square, you can do multiple things to just mark it. And then once you've marked out where your socket is, I call them pad saws because they fit in the pad of your hand. They're also called hand saws, drywall saws, all different names. And then you literally just cut out the shape of the plasterboard, and then that is where your socket would go. Over here, what we tend to do is just put the board on the wall, screw a little hole where the wire comes through, and then we cut the sockets at a later date, which is why I'm not going to cut that now. So basically what I will do is put this board on the wall. Because it's wood, I'll be using the coarse thread screws. But that would be how we would cut out the socket. Happy days. Whenever you're going to install your wall board, always make sure the floor around the area is all nice and clean, because if you get any debris, bits of wood, bits of plastic behind it, it can pop the board and stop it going flat up against the surface. And then if it's not flat, when you're going to do your skirting or your upstands and that, obviously you can put a wiggle in it, which doesn't look good. Remember, you've got two screws in, anywhere, either side or in the middle. That is enough to hold it in place. When it comes to the edge, if you've got a factory finished edge, you don't want to go no more than 10 mil away from the edge. And if it's a cut, as in you cut it yourself, it's 13 mil, that's the spec. If you go too close to the edge, basically what happens is it bulges out, and then the boards won't butt up, which if you're doing a run of boards can obviously put it out. And also it's just, that's the way you should do it. Does it matter if you come in an inch, 20 mil? No, not at all. In this application, because I know there's plenty of meat where the wood is are literally just wherever my gun sits, tidy up against it, is where the screw goes. Rather than screwing it in angle, which means the screw head isn't flush. Right, I'm going to get all these boards quickly chucked on the wall. Right, I've just put that last board in, so then when you've got another wall going into it, you'd fix that nice and solid against the other wall. Now, this is what I mean by the locking stud. So 600 centres, obviously you'd have a gap a lot of the time, so you need to put something, so that's got fixing. So when you put that to that, that's what screws together, so you get the same effect is what you have over here. So there you go, that is basically how you build a nice stud wall. I hope that helps. If you're new to the channel, because you've actually just come to watch this video, I hope I didn't waffle on too long, but if you start watching my other videos, you'll realise I like to waffle quite a lot. It's quite the thing that I like to do. Yeah, if you want to stay tuned, carry on watching. I'm now going to do this wall. So there'll be a wall built along here, there's going to be a door there, we'll get that plasterboarded, we'll get that wall built up. Happy days, ciao.